So if I ask you to solve, okay. So if I ask you to solve this equation, okay, you look at it and you think, okay, you know, it's factored, it's already set equal to 0. Basically the hard stuff's done. But to solve this, you say, well, you know, what makes this 0? So what makes this 0?
-3, 2, and 0.
Well, I'm pointing
Oh,
to
that
this.
2. Sorry, 2.
2.
Okay, 2. What makes this 0 is a 2.
Yes.
What makes this 0?
-3,
-3, right? What makes this 0?
0.
0, right? Because, I mean, some people are a little confused when how many times you have an x on the outside, but you think, you know, if this is 0, and the reason this works is, you know, if x is, let's say x is 2. Well, 2 minus 2 is 0, 2 plus 3 is 5, x is 2. 2 times 5 is 10, but that doesn't matter because when you multiply times 0, you get 0. Okay. So the significance is if you can make one of these things 0, it doesn't matter what the other two are, you still get 0. Okay. Well, let's look at a little more challenging ones. What if I give you 3x minus 1 and 2x plus 3 and 5x minus 7 equals 0?
Okay.
All right. And your goal is still the same. I want to know for this, it's already factored, it's set equal to 0. Your job is, you know, make each of these things 0.
Okay.
What makes this 0?
1/3. 0.
Well, okay, so a lot of times your first guess may be, well, like a 1 because you think it's just the opposite of the sign.
1/3.
But let's look back at what's going on here, right? See, when I say I want this to be 0, mathematically I'm saying x minus 2 equals 0. I'm actually setting this equal to 0.
Okay.
And then when I solve, that's where the 2 comes from. And if I set this equal to 0, I'll get the -3. And if I set this equal to 0, well, I'll just get 0. Well, if I look at this the same way, right, I want this to be 0.
1/3. Yeah.
Yeah. So 1/3, but if I, like, you can do it in your head, right? But you can do 3x minus, where that comes from is you're setting 3x minus 1 equal to 0, and then when you solve, you end up with x is equal to 1/3. Okay. I want this to be 0.
Okay.
And so what's this going to be?
-3/2.
Does everybody see that we get the -3 over 2?
I can see that.
Okay.
Good job.
And so I get -3 over 2. And then our final one is
7/5.
7 over 5, right? Because I set this equal to 0.
Yep.
And so I end up with 7 over 5. Now, so that's solving an equation. Now, technically I'm not solving equations today. Technically what we're doing is we're finding zeros.
Oh, yay.
Right? And when we're finding zeros of polynomials, we're going to do the exact same thing, except what you're given is a polynomial. So you're given something that says f of x equals this, and you're asked to find the zeros. And zeros are things that when you plug in, you get 0. So if anytime you're given a polynomial and you're asked to find the zeros, you think, oh, okay, what makes each of these things 0? So it turns out the zeros of this polynomial are 0, -3, and 2. The zeros of this polynomial are 1/3, -3 over 2, and 7/5. Right? Does everybody understand that's our vocabulary, right?
Yes.
Our vocabulary today is zeros of a polynomial. Right? All right, so how does it get, where do we go from here? Well, what if I gave you f of x is equal to x times x squared minus 5. I want everybody to write that down. Okay. So we go through this and we think, well, okay, what makes this 0?
0.
0. Okay. Anytime you just have an x sitting out on the side, you're going to get 0. I mean, it could be a 3x, 4x, 5x, but if you just have an x term, you're going to get 0. Oh, actually, the first question I should ask is, how many zeros are we going to have?
2.
Okay. And it turns out we're going to have 3. You get a 0 from here, and we're going to get 2 zeros from this thing.
Yeah.
Like, what you do is you look for how many x's you have. So one of our zeros is when I set x equal to 0, so that gives me 0, right?
Okay.
And the way I get my other two zeros is kind of the same way we did over here. I want this to be 0. And if I want this to be 0, that means I take this and set it equal to 0. So if I have x squared minus 5 and I set it equal to 0, now when I solve, add 5 to both sides, so I end up with x squared is equal to 5. When you solve, you're going to take the square root of both sides. And you've got to remember, anytime you take the square root, you need plus or minus. And so I have plus or minus the square root of 5. And now I have my 3 zeros. One of the zeros is 0. One of the zeros is positive square root of 5. And the other 0 is negative square root of 5.
Wow,
And so we have our 3 zeros.
that sure is cool.
Okay? All right, so what if I gave you 2x minus 1 times x squared plus 5? Well, how many zeros are we going to have? 3, right? Because it kind of looks like this one, doesn't it, right?
Yes.
We're going to get 1 0 from this thing, and we're going to get 2 zeros from this. So now let's get our zeros. All right, what makes this 0?
1/2. 1/2.
1/2, right? We can do that in our head now, right? So we know one of the zeros is going to be 1/2. And now let's think about what happens here. I want this to be 0. And since I want that to be 0, I set it equal to 0. I set x squared plus 5, and I'm going to set it equal to 0. And now we go about solving it. So if I solve it, I get x squared is equal to a negative 5. I'm going to take the square root of both sides. And so I know I'm going to get plus or minus. Let's talk about the square root of negative 5.
5i.
Yeah.
Well, there's an I.
Yeah.
Anytime you take the square root of a negative, you're going to get an I. Unfortunately, the square root of 5, there's not much you can do with it,
Yeah.
right? So we end up with I times the square root of 5. Like if it was the square root of negative 25, then you'd get the 5i. But the square root of 5, we can't do
Yeah,
anything
I meant
with.
square.
Yeah.
Yeah.
And so there,
Sure, that's what you.
here are our 3 answers.
Um,
We've got one answer. One of our zeros is 1/2. One of our zeros is I square root of 5, and the other 0 is negative I square root of 5.
Quick thinking.
Okay.
It was good.
Thank you. I did contact you.
Yep,
Now-
that's good.
Do this a little differently in this class than I did in the previous two. Of no, I'll do the same thing.
Yeah?
X squared minus 4x plus 1.
Because I.
So, everybody write this. All right, so let's talk about this one for a second. Okay? So here's a polynomial. All right. My first question is, how many zeros are we going to have?
4.
All right. So it seems like a common answer in my classes has been 4, where you think this gives you 1, and then for some reason you think this is 2 and this is 1. Right? But it doesn't work that way. You see, let's go back a month.
Well, I don't know about that one.
If we go back a month, and I give you x squared minus 4x plus 1 equals 0.
I can do that.
Okay? So if I gave you this problem a month ago, I may have given you this exact one, I can't remember. All right? So this is a quadratic. How many answers are we going to get? 2, right? Because anytime you set a quadratic equals 0, you get 2, right?
Yes.
Now, as far as solving a quadratic, what's the first thing you want to happen?
It to be a whole number.
Well, no, but to solve, what do you want to do
Oh.
first? What do you want to happen first?
Do you want to properly?
Probably factor it, right?
Yeah.
Oh, yeah.
Factor
Okay.
it.
Anytime you see x squared and x in a number, you want it to factor.
Yeah, but it doesn't.
Because if it factors, you're basically done. You do the factoring and you set each part equals 0. It's easy, right?
Complete the square.
But what happens when it doesn't factor?
Complete.
Which is what this does, right?
All the work.
Complete the.
Then
Quadratic formula.
quadratic formula. So let's see. So as far as quadratic formula goes, negative b. So I get 4 plus or minus the square root of this squared minus 4 times 1 times 1 all over 2 times 1. And I always do a little, instead of copying the whole thing down again, I'll look here and I'll say, well, that's negative 4 squared is 16 minus 4. So we end up with 4 plus or minus the square root of 12 all over 2. Okay. And square root of 12, we can clean that up because that's 4 and 3. So if I think of that as 4 and 3,
2, 3.
so when I simplify this whole thing, this is going to give me 4 plus or minus 2 square root of 3 all over 2. And if you got something here, I actually want you to clean it up a little bit more because you can simplify this.
Yeah, the 2
Uh,
cancel out.
Well, you can factor out a 2. The safe thing to do would be to write it as 2 fractions.
Oh, okay.
Because if you wrote it as 2 fractions, you'd have 4 over 2 plus or minus 2 square root of 3 over 2. Now when we cancel the 2's, this is going to give us 2 plus or minus square root of 3.
Yeah.
Right? We have 2 answers, 2
Oh,
plus
yeah.
square root of 3 and 2 minus square root of 3. All right, so now let's look back at this problem. The original problem was I want to know the zeros. Right? So if you look at how many total zeros we're going to have 1 from this thing. And because we have a quadratic, we're going to have 2 from this one. So what's my 0 from this thing?
Negative 3 over 2.
Okay, so this one's going to give me negative 3 over 2. And the zeros from this thing we've already computed.
Yeah.
All right, one of them is going to be 2 plus the square root of 3, and the other is going to be 2 minus the square root of 3. Everybody see how that worked?
Yes.
Okay. So, your turn.
Yes. Yay.
F of x is equal to 2x minus 5 times x squared plus 6x plus 13. So one of the first zero is easy, right? You look at that, you can do that in your head at this point. We know we're going to get 1 0 at 5 over 2.
Yes, I got that one.
For the second one, right, we have to set this equal to 0, and you hope it factors, but unfortunately, it doesn't factor.
Darn it.
All right. So since it doesn't factor, we're going to have to use the quadratic formula. So that's going to give me negative 6 plus or minus the square root. This squared minus 4 times 1 times 13 all over 2 times 1.
I got that.
Well, let's see, that's 36 minus 52. So I get negative 6 plus or minus the square root of negative 16 all over 2.
Yay.
Since I've got the square root of a negative, what do we know we're going to have?
An I.
We've got an I.
Yeah.
So this is going to simplify to negative 6 plus or minus 4i all over 2, right? Square root of 16 is 4.
Oh.
Okay.
But we can clean this up.
Yeah. Negative 3.
And this is going to clean up as negative 6 over 2 plus or minus 4i over 2. Which is going to give me my final answer of negative 3 plus or minus 2i. So my other two answers are going to be negative 3 plus 2i and negative 3 minus 2i.
This is a lot.
Okay.
Uh-oh. I'm confused now. I see it.
Okay.
There you go.
All right, so it's when we're finding zeros, you like to see them factored. You really like to see them factored if there's no exponents. But if there's an exponent, if there's a squared exponent, you go, all right, maybe hopefully it factors. But if it doesn't factor, then you're forced to use a quadratic formula because you're looking for those zeros. All right. So let's look at sort of the next level up.
You don't have to.
So let's give you x to the 4th minus 5x squared minus 36.
Oh, this would be.
It's like a quadratic, isn't it?
Sure is.
Because remember, this is half and it's a number, right? So we could factor this, we treat this just like a quadratic. Oh, also, actually before I started this whole thing, how many zeros are we going to have?
2.
Sorry. 2.
Okay, turns out, okay, whatever your highest exponent is, in this case it's 4, this is the degree of the polynomial. whatever the highest exponent is, that's how many zeros you're going to have.
What in the world?
Right?
Yeah.
Since this is x to the fourth, we are going to have 4.
Okay.
So how do we find them? Well, we factor like we've been factoring. This is, if I treat this like a quadratic, then I can factor this as x squared and x squared. How many get to 36?
Plus 6 minus 6.
I don't think that's going to give me a 5.
Yeah,
Yeah,
it's not
yeah.
9 and 4. So you
I think
can
9 and 4.
Nine
Right?
and 4, yeah.
Okay.
Negative 9.
So I'll do minus 9 and a
Plus
plus
four.
4.
Yeah.
Right? And that minus 9x squared, minus 9x squared plus 4x
Yeah.
squared, that gives me the minus 5x squared.
Okay.
And so now they're factored, right?
Yeah.
So, and if I want to find zeros, I want to set this thing equal to 0, and I want to set this thing equal to 0.
Okay.
Well, if I set this thing equal to 0, that's x squared minus 9 equal to 0, x squared is equal to 9, take the square root.
Plus 3 minus 3.
I get plus or minus 3. If I set this thing equal to 0,
Oh, that's different.
x squared plus 4 is equal to 0. Get x squared is equal to negative 4. Take the square root of both sides. What are we going to get?
2i. Or square root of 2i.
No, 2.
Oh, 2i.
Yeah,
Okay.
because the square root of 4 is 2.
Yeah.
And there's a negative, it's square root of a negative, so I'll have plus or minus 2i is x.
Yeah.
Hey, and there's our 4 answers. Our 4 zeros. We have 1 0 at 3, 1 plus or minus, plus 3 minus 3. We will get 1 at 2i
And negative.
and 1 at negative 2i.
So it's kind of like what we used to do.
Yes. Well, that's kind of, that's what this chapter does.
Okay.
Pretty much everything we've done up until this point is all background knowledge so that I can teach this. Right? So,
I feel like you should have the same math teacher all 4 years of high school stay now.
well, that's if you,
That would all be awesome.
well, it depends on if you like the teacher or not, right?
Well,
Our guys.
I think the teacher's relationship would fall apart after a year.
All right, so what about if I give you x cubed minus 8? Everybody write that one down. Okay,
They
Found all
agree.
what?
No, you definitely.
I found all 3.
You found all 3?
Yep.
No,
Oh, wait.
He's lying to you.
All
I don't
right,
believe it's true.
so this is degree 3, so yes, I do agree that 2 is a 0.
Yes.
You're absolutely right that 2 is 0. The problem is, since this is x cubed, we better get 3 answers,
Yeah.
right? So how do we find them? Well, can we factor this?
You can.
No.
You can.
you can.
Yes, yes, you can.
What is it?
X cubed.
It's a difference of
The
cubes.
cubes, yeah. It should be x minus 8, and then you square.
See, think of that 8 as 2 cubed, right?
Yes.
So we can factor this.
Okay.
We can factor this as a 2-part thing and a 3-part thing.
Oh my god, that's too many
Oh,
things.
yeah.
Whoa, calm down.
So what's the 2-part thing going to be?
X minus 2.
X minus 2, we drop the cubes. right? So that gives us x minus 2. And then once you get the 2-part thing, the way you get the 3-part thing, you square this and stick it here.
The squared.
You square the last thing and stick it here.
Four.
You're going to multiply those together.
4x.
Multiply these together, you 2x. And then these signs are the same, these are opposite, and that's always positive.
So, no,
Yeah.
so, right?
Now,
Oh,
Okay.
I have a question.
Yes.
So do you square the entire thing or only the first and last?
just the first and last. Okay, now,
Thank you.
so now we've taken this and we factored, and now we have to, we treat this kind of like we treated those couple of problems we did. What makes this 0?
2.
2,
Are you
right? There, so Grant, there's your 2, right? And
You have to.
Yes.
Quadratic
Oh,
formula
how
of
will
that.
we know when to like leave it at that or keep doing it?
Because.
well, if I tell you find all the zeros,
Until you find.
if you've got 3, if this x cubed, you better have 3 zeros.
Right.
He just puts the second
Okay.
thing as his answer.
Okay. So, x equals 2 is an answer. Grant said that earlier, and you're absolutely correct.
Yay.
All right?
Let's keep going.
And for this one, right? Now, just so you know, whenever you do a sum or difference of cubes, this never factors, so don't worry about trying to factor it.
Bruh.
Well, since it doesn't factor, guess what we have to use?
Quadratic formula.
Quadratic equation, right? Quadratic formula. So plus or
Wait,
minus
I have a
square
question.
root of b squared.
b squared
Minus 4ac.
4 times 1 times 4 all over 2 times 1. Yes.
If you ask us to factor difference of cubes completely, that would be the answer, right?
If I said factor it completely, that's the answer. But if I say find the zeros,
Okay.
then you have to come up with these numbers.
No, that's not what you're asking.
More. Oh, this is not.
So that ends up being 4 minus 16.
So then you use 4i. Or it's not.
So I get negative 2 plus or minus the square root of negative 12 all over 2.
Hey.
As far as dealing with, first it's square root of negative, so I know I've got an I. And then as far as dealing with square root of 12, that's a 4 and a 3. I end up with negative 2 plus or minus. That ends up being 2i square root of 3 all over 2.
And you can factor for, or you can, yeah, factor for that.
And then I have to clean this up. Right? Yeah, because the 2 goes into both. Like if you were to break this apart, if you were to break this fraction apart, you'd have negative 2 over 2 plus or minus 2i square root of 3 over 2. So that'll give me a negative 1 plus or minus I square root of 3.
Yeah, I got that.
So our 3 zeros are, this gives me a 2, and then I get negative 1 plus I square root of 3, and I get negative 1 minus I square root of 3. Okay. Now, so this is, so the good news is this is the hard part of today. Okay? So the hard part of today is given some sort of polynomial, how do you find its zeros? Well, you have to factor. Sometimes it's factored for you, and that's great. If it's not factored for you, like these two, then you use the techniques we've talked about to factor it and set each part equal to 0. Okay? So now we're going to go backwards. Now, here's how backwards works. Okay? So if I get, what I mean by, what we've done so far is I've given you the polynomial and you've given me the zeros. Now what I'm going to do is I'm going to give you the zeros and you have to give me the polynomial. So if I give you zeros of like 1, negative 2, and 3, and here's how I want you to think about it. If 1 is a 0,
You can do x minus.
what's going to be down here?
X minus 1.
An x.
Oh, we did this when we were graphing.
Yeah. So if 1 is a 0, are we okay that x minus 1's going to be here?
Yes.
X plus
Yeah.
2.
Okay. If negative 2's here, we're going to get an x plus 2.
X minus 1.
And if a 3's here, we get x minus 3. Now, unfortunately, we're not done.
Yeah, we are.
No. Because you have to multiply it out.
Oh.
That's not so bad. See, to multiply it out,
You just, easy.
I always pick these two. I pick the 2 to the right, because you can do this in your head now. Because we've been doing this enough. Because I mean, we're going to get 3 terms. This times this gives me x squared. This times this gives me negative 6. 2x minus 3x is a minus x.
How do you get that? Oh, I see how you get that. I see how you get that. Don't worry about it.
And then you bring down the x minus 1. And now we distribute, now we multiply this out. So this times this is x cubed
Oh, wait.
minus x squared minus 6x minus x squared plus x
Why?
plus 6. And so I end up with x cubed minus 2x squared minus 5x plus 6.
Wow.
Okay?
Yay!
Do you see how I'm trying to pull in a lot of the ideas we've used.
That was really so much fun.
No. I wish I could go back to the days of rocket math.
All right, so how does it get a little trickier? Well, what if I give you zeros my zeros are 1/2, -2/3, and 0.
I can
Okay.
do that, just
So
give me a
X
second,
minus
please, Drew,
half.
don't say it out loud.
Oh,
Two
we know
X
when.
minus one.
Okay, okay, perfect. Okay, now, what I've noticed, particularly in the other classes, if 1/2 was a 0, people are already telling me 2x minus 1, and that's great. That's exactly where you need to be.
But you need an X because there's a
You-
zero.
If there's a 0, or y'all already know how to do this. Great.
Stop.
Okay, but I still want to talk just a little bit, right? Let's say for a moment that you treated this the same way you treated this problem. Like some students will look at this and you say, well, if there's a 1, I better put an x minus 1. If there's a 2, I do x minus whatever's up here.
Better one.
Let's say that you approach this problem that way. Let's say I approach this as x minus 1/2, x plus 2/3, and because there's a 0, I know there's an x.
X, yeah.
What?
Okay? But your final answer, the way these questions are always stated, is, I want integers. I want integer coefficients, which means no fractions.
X.
Okay.
So how do we actually get rid of these fractions? Well, what I want to do is get rid of that 2.
Yeah, you just multiply.
And the way I get rid of that 2 is I'm going to multiply by 2. And look what happens if I distribute the 2. What do I get?
Well, then you get 2x minus
I get the 2x minus 1. And what am I going to do to get rid of this 3?
Multiply by 3,
I'll multiply by 3, and that's going to give me
3x plus 2.
3x plus 2. And that x here, I'm going to go ahead and put that in the front. Again, we're not done, because I need to multiply it out. But multiplying this out isn't hard. You multiply these two together, and then when you're done, distribute the x. And multiplying these you can do in your head. This is going to give me 6x squared minus 3x plus 4x gives me a plus x, and then I get a minus 2. And all that's left is to distribute the x. And so we end up with 6x cubed plus x squared minus 2x. Now, I need to press pause.